Alrighty guys, we're going to graph in another form today. So we're going to talk about graphing in standard form. So we kind of looked at standard form a little bit already because when we were doing our quadratic regression, we were putting that into standard form. That was with the ABC. And also the other day when we were talking about vertex form, we took something that was in vertex form and put it into standard form. It's also important to know, like, if you're in standard form, how can I graph so that I don't have to change back and forth between forms? We can just do it. So we're going to set this page up a lot like the one we did for vertex form. So you'll have this note card here, your book on 32, and then on 31, I'm going to put a little half sheet of graph paper for a few extra examples, and I might do that one in a separate video again. Now, the bummer here is we are going to have to glue over this example 3, but I might write it out for us to try. So that's that. Let's dive right into it. So when we are in standard form, A, B, and C all tell me something about my graph, but they're not the same as, well, they're not all the same as A, H, and K. One of them is the same, and that's A. So yesterday, when we were talking about the A value in vertex form, that was slope, still slope, okay? And then when I say slope, I guess I mean slope in quotes because it isn't slope forever. It's only slope once, and I have to do it as rise over 1. I can't, like, if it's half, I can't go up 1 over 2, okay? So 2 things we got to remember when it comes to slope. The B is kind of weird and unfortunately doesn't, like, show me a, like, direct point on the graph. However, C is kind of a helpful point. It is our Y-intercept. Like, if you think about the Y-intercept, the way we find it is we always put 0 in for x, and so that would zero this term out and this term, and you'd just be left with this. So 0 comma C is your Y-intercept. Now that's all well and good. That is a point that we liked to find yesterday when we were talking about vertex form, but it's not the most important point. The most important point of a graph, of a parabola graph, is always the vertex. And so I really have to have the vertex. And unfortunately, it's not like I can't just go grab it out of my equation. I have to do a little baby formula to get it. So the little baby formula that you're going to do to figure out the x value of your vertex is you're going to do negative b divided by 2a. And then let's say you come up with 2. Then you want to take that number and plug it in to get y. Okay, so like you take this number, plug it into your equation to get the y value, and then you have your vertex. You also have your axis of symmetry because it'll be at this x value here, which is negative b over 2a. So then you'll have a lot of helpful things. You can plot your vertex, you can draw your line of symmetry, you have your slope that you can do once and flip over, put on the other side, and then your y-intercept, which is super easy, no math necessary. You can flip it over and put it on the other side. So, steps for graphing success. A lot like yesterday, you really have to always do these things. The first thing you should always do is find that vertex. Find and plot the vertex. Yesterday it was easy. I just had to grab the numbers out of the equation. This time it's less so. So the way we find and plot our vertex is we got to do that little baby equation, negative b over 2a, and then plug it in to get the y value. Now we also can then draw our axis of symmetry through x equals negative b over 2a, whatever that is. So same steps as yesterday, it's just this first step requires more work. The second step is exactly the same. So the second step is we want to use A as slope once and as rise over 1. And then the third step is the same as yesterday, except this time it's much easier. Yesterday when we had to find the y-intercept, I had to like plug in 0 and do some math to figure it out. This one will be easy. So we're going to find the y-intercept and plot it. I just have to look at my equation and look at the c value, the one that is all by itself, not on an x. And then I just go plot it. So that one is super duper easy. So that's kind of what's going to happen with each of our graphs. There'll be like one part that's easy and one part that I kind of have to do some math for. So let's jump in and try some. So graphing a quadratic in standard form, our quadratic equation is y equals ax squared plus bx plus c. Parabola is the shape. It's in either a pointing up parabola if we're positive, or a pointing down parabola if we're negative. The vertex we find by doing that negative b over 2a and plugging in. And then the axis of symmetry is that x equals negative b over 2a because it's right on your vertex. Whole bunch more information here. I think I'm going to actually come back to this one. Let's jump to example 1 where we're going to start graphing. Okay, so I can tell that I'm in standard form because we got x squared x, no x. And so a is 2, b is negative 8, c is 6. Always make sure we take the sign in front of it. I can actually tell right now that this graph is going to open up because a is positive. Then we really find our axis of symmetry first because that negative b over 2a, although it's part of your vertex, it's also your axis of symmetry. So we're going to do negative b, which is negative 8, over 2 times a, which is 2. So the double negative will make it positive. So really this negative b thing is just always going to change the sign of your b, whatever it is. Okay, so positive 8 divided by 4 is 2. So I know my axis of symmetry is at 2. I can draw that in. I also know that somewhere along this line, like either real high or real low, is going to be the vertex. So to find the vertex, part of it is 2. The y part of it I have to plug in to figure out. So what we're going to do, 2 times 2 squared minus 8 times 2 plus 6. So we're just putting it in place of x. So 2 squared, and we're just going to follow order of operations now. So 2 squared is 4, times 2 is 8, minus 16 plus 6. And that's going to be what? Negative 8 plus 6, so negative 2 is where my vertex is. So negative 2 goes right there. I can tell right now that this vertex is going to be a minimum, and that's because we're going to come up from here. And I can start doing that right now by using my slope. So my slope is 2, so I can go up 2 over 1, flip it over, put it on the other side. And then I can also do that again with the y-intercept. Now the y-intercept, I don't need to do any math. It's just always your c value. So 0, 6. So I plot the 6, and then flip it over, put it on the other side. And I think that's what that paragraph at the bottom is just telling us about. So we're going to make our smooth curve. Yep. Cute. Let's try another. So, taking a look at this one, I think we're missing a letter. So next to x squared is always my a value, so like negative 1/2. Next to x is usually my b value, but there is no x. So that must have meant that b was 0. And then c is 3. So I can tell right now that my parabola is going to open down because A is negative. Then I should go find my axis of symmetry. So like if we think about the steps here, we want to find our vertex, which part of that is getting the axis of symmetry by doing negative b over 2a, using that little baby equation. So negative 0, that's awkward, over 2 times negative 1/2. I can't really have negative 0. I think 0 over anything is just going to be 0. Now the bottom is negative 1, just so you know, like don't freak out about that fraction. That's just half of 2, which is 1. But if 0 is on top, overall you're just 0. So for my vertex, I can draw in my axis of symmetry. Let's get that going. I'm going to do it with a color because since it's 0, it's on the y-axis, so that's kind of hard to see. Okay, so for the vertex, I know the x value is 0 because it's on my line of symmetry. And then to find the y value of it, we're going to plug this in, which maybe some of you are realizing right now this is a bit sus because normally I plug in 0 to find my y-intercept, so I'm pretty sure right now I'm finding the vertex and the y-intercept. Oof. And the reason I say oof is because like that's a bummer. We won't have like 5 nice points like we like to have when we're graphing. However, once I have my vertex, I can use my slope of down half over 1. So like from here, we're going to go down half over 1. Flip it over, put it on the other side. And I can tell right now because my graph is doing this that I have a maximum. So like that's the top point of the graph. Now the bummer is, like I said, I don't have 5 nice points. So what you could do if you want your parabola to look real nice, like I have already the x values at -1, 0, and 1. So what I could do is I could plug 2 into my equation to find another nice point and then like flip it over on the other side. So we can do that. We'll just say like, let's say x is 2, and then we plug it in. So -1/2, 2 squared plus 3. So 2 squared is 4. Half of that is 2, and it's negative. Plus 3 is negative, oh, no, positive 1. That was almost a disaster. Okay, so I can plot the point 2, 1. And then I can flip that over and put it on the other side. And now I have like a slightly better looking parabola. I mean, it's okay if you don't go find that last point, but just having 5 points kind of makes your parabola look a little nicer. Okay, let's go back and talk about a couple of things here, just as a reminder. To find the axis of symmetry, we're going to do -b over 2a. The vertex has an x-coordinate of that, so -b over 2a. We're going to substitute whatever that is back into our equation to find y. My parabola is going to open up when a is bigger than 0, because that means positive. My parabola is going to open down when a is less than 0, because that means it's negative. Because my parabola points up or points down, sometimes I have a minimum or a maximum. So the vertex is a blank when the parabola opens up. So when I'm opening up, the vertex is at the bottom, so like a minimum. It always makes me feel so awkward because like up, I think max, but it's kind of opposite. And then a maximum when our parabola points down. The y-intercept is always easy. It'll always be at 0, c. No math needed to find that one. The parabola will be narrower than its normal graph, so like going faster if we are bigger than 1. So like it'll be skinny because it's going fast. And wider if a is less than 1. Now this is the absolute value of a because The positive and negative has nothing to do with that. That tells me if I open up or open down. If my number is bigger than 1, so like 2, 3, 4, 5, 6, then we're skinny or narrow. Absolute value of A less than 1 means I'm something like half or 3/4, or fractionally less than 1, but bigger than 0. The slope A will find points in the parabola that are 1 unit away on either side of the vertex. So that's all that stuff that we kind of already knew. Now, I know that you don't have this one because you're going to glue it down, but since I didn't have to glue it down on this, I'm going to do it. And so if you want to hang out and see how I would do this story problem, you don't need to write it down or anything. So a woodland jumping mouse hops along a parabolic path by the equation blah, 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 where x is the mouse's horizontal position in feet and y is his corresponding height in feet. So like if you kind of think about it, I mean, I feel like this has to sort of look like that, where like he starts here and hops to here. So horizontal distance, and we have vertical distance, so like how high he is off the ground. Can the mouse jump over a fence that is 3 feet high? Well, I feel like I want to know how high the mouse can jump, because if he can jump 3 feet or more, then he'd be able to make it, and if not, then he can't. So I feel like I really just need to know what the vertex is and like how high it is, and I'll know if he can make it or not. So taking my equation right here, oh, it totally makes sense that my graph would look like this because we have that negative a value. So this graph should be pointing down. And then to find the vertex in standard form, we want to do that negative b over 2a, and then plug it in. So negative 1.3 over 2 times negative 0.2. So overall this is going to be positive, and then we're going to be 1.3 over 0.4, which does that go in evenly, like 0.3? I don't know. Decimals are freaking me out. Let's just grab that handy dandy calculator. Freaking a decimal always just makes me so nervous. 3.25. That's kind of what I thought. Okay, so right now, don't get excited. This is x, and x is how long. So like when I start jumping to when I land. I want to know how high, because I got to get over a fence. So I think I need to plug this in now to find the y value. So we'll have negative 0.2 x squared, so 3.25 squared, plus 1.3 times 3.25. So again, handy dandy calculator time just because decimal land. So I'm going to square this and multiply it by 0.2 and make it negative. So I got, sorry, this is going to come up here because of space, negative 2.1125. And then I'm going to multiply here, so the 1.3 times 3.25 for 4.225. And then I'll add that to the negative 2.1125. I get 2.1125. That's interesting. That's interesting. Which I feel like tells me this mouse is not going to make it. He's only jumping 2 feet up into the air, a little extra. He's not going to make it over that fence. No way. He needs a whole nother foot. Sad. All right, I'm going to make another small video where I do a couple more graphs on this graph paper here just in case you need it.